Croeso, welcome. My name is Elion Rhines from the Further Mathematics Support Programme in Wales. Mae mathemateg I bawb. Mathematics is for everyone. On the screen, examples of various people can be seen, all mathematicians, and in this series of videos, we would like to highlight some of the influence and work by such people. I will focus on examples of art connected to mathematics, in particular art using the property of fractals. To demonstrate this, we will look at some work by Fazila Patel, and then that by Werner Olivier, Flora Olivier, and Arnold Gwaze. There are a lot of important and significant texts involving the writing of mathematics. However, mathematics is in itself a diverse subject in that it induces many visual and picturesque representations of itself, which I hope comes across in this video. We first look at some work by Fazila Patel. She is a high school math teacher at Kansas City Academy at Missouri in the USA. She loves to dance with fractals. They can represent the spontaneity of her life. Every step depends on the next, and this recursive nature turns into a meditative rhythmic movement of shapes, colours, flow, and form. Fractals are objects which have the property that given a shape, and upon zooming in on a specific part of that shape, you can see once again that original shape. Zooming in again and again wins back that shape over and over. This is what Fazila refers to by every step depends on the next and their recursive nature. Recursive properties crop up in various areas of mathematics, but a notable example is in sequences of numbers, where a given number in a sequence is generated using preceding terms in that sequence. A very famous example is the Fibonacci sequence, where adding two numbers gives the next number in the sequence. Akin to what I said earlier, Fazila's work on fractals gives a visual take on recursiveness, rather than a written example as we see on screen. This piece of work by Fazila is called The Wall of a Young Maiden. It was designed using fractal, in fact using Apophysis, a fractal generating software, and it is to incur a light, soothing and calming effect. The image represents a wall that belongs to a young woman maiden, the artist herself. We can recognize the characteristic property of a fractal in this work by observing this petal pattern in the middle, and spotting that the same petals can be seen either side to it, contained in a ball. Zooming in on each of these balls gives two further copies of the original image. This property continues upon zooming in on each of the balls. Hence, the recursive property is apparent. What is also nice about this piece of work is that it is an elegant example of symmetry and rotational symmetry. One can find that it is symmetrical about the x-axis. Notice it creates a mirror image of itself across the line. The y-axis, again a mirror image. The line y equals x, as well as the line y equals minus x. Rotating the work can show us rotational symmetry. In fact, in its rectangular border, as seen on screen, it has a rotational symmetry too. What this means is that we can rotate the image twice before it gets back to its original position, where on each rotation the image appears as it did before rotating. This is probably easier shown than said. With this image here, a rotation by 180 degrees is as so, and notice although the image is now upside down, it still appears as it did before rotating. And then rotating a second time by 180 degrees gets it back to its original position, where of course it appears as its original self. So that is an example of rotational symmetry too. We will not spend as long on this piece of art, but this is another nice example from Fazila. This piece is called Lazy Autumn, and it is again a fractal art designed using Apophysis. Where here, each leaf is the result of smaller leaves. In terms of mathematics, each leaf's shape and design is a fractal that gets progressively smaller. Similar to the previous slide, I'll demonstrate this here. Focusing on a particular smaller leaf in the work, zooming in just gives the same leaf again. We continue the theme of fractals by looking at one final piece of art. This is Fractal Tessellatum Africa by Werner Olivier, Flora Olivier and Arnold Gwaze. I will speak more about these artists on the next slide. The recursive property of a fractal can be seen here in the shape of the map of Africa. Notice that within each shape of the map, a further smaller shape of the map is contained inside it. This work is also a good example of geometric decorative patterns used with natural material or materials in a mixed medium, such as seashells and seed beads, which are widely used in African art to this day. A further feature of the piece is the tesserae across the fractal pattern, which was done with traditional South African shwe fabric, which represents the rich and diverse celebration of mathematical patterns on the African continent. To think more about the artists themselves, the inspiration behind this artwork is a desire to collaborate in creating an original African statement about historic connections between mathematics and art. This is evident when we know more about their background. They are employed at the Nelson Mandela University in Port Elizabeth, South Africa, and in their academic work they engage with learners from poor communities. Including in this is promoting STEAM education, as well as learning through experience and observation with problem-solving designs using tessellations, fractals, and other geometrical shapes of cultural origins. As a side note, STEAM education is a way of learning using science, technology, engineering, the arts, and maths for encouraging students to inquire, to dialogue, and to think critically. In reference to the photo on screen, Werner Olivier is on the left. He is a mathematician who likes to work with art in STEAM education. Flora Olivier is in the middle, and she is a retired electrical engineer and artist. And on the right is Arnold Gwaze, a maths educator, STEAM enthusiast, and amateur artist. This brings to an end this short presentation on some mathematicians connecting art to mathematics. Here I note some useful links and sources relating to the work seen in this video. A notable one is the first, which in fact was the main source used for putting together this video. The Bridges Linz 2019 is a catalogue of artworks that each connect some art to some mathematics. The artwork in this video is just a small sample of the various art that can be found in this book. In fact, the quotations seen in this video were taken from the pages in this book dedicated to the art and artists that I have discussed. The second point is a link to an online gallery of the work seen in Bridges Linz 2019, and it has art from exhibitions from other years as well, so even more art and mathematics to explore there. The third point is a link to a YouTube video of a well-known example of the recursive property of a fractal, the Mandelbrot set, so that could be a fun and even quite mesmerizing watch. And lastly is a link to our website at the Further Mathematics Support Programme Wales, furthermaths.wales. In particular, it is to the pages on our site for Mathematical Worlds, which was a series of 10 investigations which were produced on behalf of us in the summer of 2020. They typically include a video as well as handouts of questions for students to explore and handouts for teachers should they want to help with the answers. This series covers a wide range of mathematics in various contexts, so I would recommend you have a look at these to see more interesting maths. Having shared all these links and sources, I will end the video here. Thank you for watching and I hope that you have enjoyed.